Hello everybody, my name is Anya Kantra. So today I'm here with another video of the subject Theory of Computations. So let us look into the contexts. So the index is about the abstract, introduction, literature review, research methodology, outcomes, and the conclusions. So let us look into the abstract of this research paper, which I've prepared for the TOC subject. So one of the most important tools in formal language theory is a pumping lemma for CFLs. It proves a particular language is not a context-free. However, due to its complexity, it can be difficult to formalize and apply inside an automated reasoning system. This paper surveys a few applications of a formalized version of pumping lemma for CFLs, demonstrating how this formalization can be used to automate proofs about the language non-membership. Techniques for encoding the lemma within the proof assistance are presented, along with the examples of its use in verifying non-context-free languages and some implications for formal language theory and automated verification tools. So we shall illustrate the benefits of the formalized approach to the lemma for more robust and reliable proofs in theoretical computer science. So the introduction for pumping lemma in CFLs is one of the most important tools in formal language theory. It is used mainly for identification and characterization of non-context-free languages. While it is very useful, the application of pumping lemma is usually complicated and involves a lot of manipulation with deep understanding of the properties of languages. Recent developments in formal verification and automated reasoning have made formalizing the pumping lemma for CFLs of interest within the automated proof system. This could make proofs involving the language non-membership easier and shorter and provide a more stern approach to the language analysis. This paper discusses the application and benefits of formalizing the pumping lemma for CFL with the framework of automated reasoning frameworks. It establishes that this approach, which has been formalized in some sense, is good in terms of improving the effectiveness of the properties that are not of the context-free type on proof related to languages, automatically saving efforts and human related errors, possibilities that might prevail when using traditional methods. So we shall use practical examples and case studies to provide the insight into how the developed formalism can be helpful towards automating the theorem, improving efforts in theoretical computer science without confining it to its scope within the specific applications. So the literature review of the pumping lemma for context-free languages has been a part of the formal language theory for a long time, used to demonstrate that certain languages are not in the class of context-free languages. The classical treatments like the Hopcroft and the Ullman gives theoretical underpinnings, but laborious manual proofs have to be used in practice. Recent advances in the automated reasoning have motivated attempts to formalize the lemma inside proof assistants, such as Coq and Espel, which can be used to give automatic proof of properties of languages and the membership problems. As an example, Nipkow and Klein demonstrated how such tools can be used to mechanize the intricate proofs in formal languages, but the pumping lemma has not yet been used in its entirety. This paper builds on this body of work by implementing and exploring the practical uses of the formalized pumping lemma, thereby filling a gap hole in the literature and helping further the utility of formal verification and language theory. So coming to the research methodology, the study employs a formalization-based approach to the pumping lemma for context-free languages using automated proof assistants. We begin by encoding the lemma with an proof assistant, such as Coq and Espel, to capture its logical structure and constraints accurately. Next, we apply this formalized lemma to a series of test languages to verify non-text freeness, assessing the accuracy and efficiency of the proof assistance output. We also compare these results to traditional manually constructed proofs to evaluate the formalized methods, reliability, and time efficiency. By analyzing various examples, we assess the practical applications of the formalized lemma, automating the proofs within the theoretical computer science. So coming to the outcomes of this project, this research paper of the subject TOC, there are several significant applications of formalizing the pumping lemma for context-free languages inside automated proof assistants. First, our finding demonstrate that formalized work can correctly test for non-context freeness in many languages. It provides automation of proofs, often cumbersome to obtain manually and save potential human fallibility in lengthy proofs. The formalization of the pumping lemma is also helpful when scalability in its application across the complex languages and non-context free properties that are extremely hard to prove using simpler approaches. Generally, this is a very vigorous framework for computer science theory applications, and it supports the reliability scope of the language analysis and automatically based systems. Coming to the conclusion, the formalization of the pumping lemma for context-free languages in proof assistant is a significant step forward in formal language theory and automated reasoning. Automatic proofs of language non-membership are possible now, which reduces the manual effort and the risks of the error that comes with traditional proof methods. In practice, our research proves the reliability and the effectiveness of applying such an application of pumping lemma for different wide class of languages. Further, this work would put a basis for formal verifications that could further expand development in this field of logic, which implies that this type of reasoning may help with the both depth and reliance levels of formal proofs for computing the theoretical subjects. So thank you for watching my video. Please do like, share, and subscribe to my YouTube channel, and please stay tuned for more informative video assignments like these. Thank you all.